Okay, in this lecture, we're going to go over how to make frequency polygons for the final project, and also how to, well, yeah, that's pretty much what we're going to do. So I'm going to go ahead and share my screen with you. Let's see here, and we're going to go into Canvas. So your Canvas should be, let's see here. Loading it up. So if you go to your Canvas, you might be able to find it under Final Projects, and I will put it right here with how to make a frequency polygon because it goes with independent samples. So I'll put it right here, and then I'll also put the Excel file to download it there as well. Right now I've got it right here, car data to work on in class. So I'm going to go ahead and download that and open it up. So if you want to, you can work through the entirety of this, but we're not going to work through the entirety of this. We're just going to make the frequency polygons, and that's it. There is a whole section here on how to make box plots as well, box and whisker plots, and how to interpret that. But yeah, let's look at frequency polygons. So frequency polygons. First thing that we're going to do is, well, first let's look at this question. Is the average track time for cars with rubber wheels greater than the average track time for cars with plastic wheels with an alpha of 0.01? So we want to know, hey, we've got rubber wheels, the track time with rubber wheels, the track time with plastic wheels. Are rubber wheels track time greater than the average of plastic? And so first thing that I'm going to do is I'm going to just click anywhere on here and insert pivot table. And I am going to, it automatically highlights everything for you. And then I'm going to say, hey, I want it in an existing worksheet, and I want it, we'll put it right down here. Okay. And so we're going to start with cars with plastic wheels. And I know normally we always start with cars with, we start with the left one, but there's a reason why I want to start with cars with plastic wheels. And that's because cars with plastic wheels has 809 observations, and cars with rubber wheels only has 67 observations. And so we want to start with the one that has more observations. So what you're going to do is you're going to do cars with plastic wheels, put it under rows, and also put it under values. And so we've got the value, we've got all these values right here, the value of the observations, and then over here it says sum. We don't want sum. We want to show value as percent of, no, sorry. We want to show value as no calculations and summarize values by count. And so we want a count of each one of these. So we've got a count of 2.79 occurred once, 2.86 occurred once, so on and so forth, going all the way down. And the next thing that we're going to do is we are going to group this. Well, in order to group this, we need to know a few things. First of all, we know that there are a total of 809 observations. And if you want to, you can go to the end of here. It also says 809 observations. And so we're going to do n equals 809. Now the question is how many classes should we have? And if you recall back in Unit 1, we did this by using the 2 raised to the k is greater than n rule. And so what that is what is the first, what is the first value, or the first k, or the first number of classes that if you use this many classes, it would be greater than n? And let's, I feel like I'm not saying that correctly, but let's look at what that would be. So this is going to be k, and this is going to be the product of 2 raised to the k. So equals 2, or actually 2 raised to the k. And so let's do equals 2 raised to the whatever this is right here. And we're just going to drag this down. We'll start with 5, 6, 7, 8, 9, and just drag it down. And the question is, what is the first 2 raised to the k that is greater than 809? So 2 raised to the 5th is 32. That is not greater than 809. 2 raised to the 6th is 64, not greater than 809. 2 raised to the 9th is 512, still not greater than 100 or than 809. 2 raised to the 10th is 1024. That is greater than 809. So we should have about 10 classes. It doesn't need to be exactly 10 classes, but about 10 classes. And so K, we're going to do K equals 10. Okay, the next thing that we need is we need the range, which is going to be, let's bring this down here. So that way, okay, range equals max minus min. Okay, so we've got the max value down here, which is 6.62. We've got the min value, which is 2.79. So we've got 6.62 minus 2.79. And let's go ahead and figure out what that is. We could just put equals, okay, and the range is 3.83. So we've got a range of 3.83, and in order to okay, that's 10, 809, okay, range, and now we need to know the class interval, which is going to be range divided by K. And so we've got our range right here, which is 3.83, and K, which is 10. So we're going to do equals range divided by K. And that tells us that each of our classes should be about 3.83 seconds in width. And so looking down here, first of all, I don't really want 3.83 seconds. I really want something closer to like 0.4. And so I'm going to make it so that it's much cleaner with using 0.4. And so I'm going to have class interval that I'm going to be using is going to be 0.4 unless I go through this and I just don't like what it looks like. So I come over here and I've got all these values and I'm going to group them. And so I'm going to say group. And with grouping these, I'm going to start. Okay, where should I start? I don't want to start at 2.79. I want something that's going to be really nice and round and pretty. So I'm going to do 2.6. So starting at 2.6, and I'm not going to touch where it ends. And what am I going to group it by? I'm going to put it in groups of 0.4. And one of the reasons why I'm starting at 2.6 and not like 2.5 or something is 2.6 plus 0.4 equals 3. Plus 0.4 is, 3.4. It's just really round when you start with 2.6 and it goes straight to 3. So we're going to do that. And that gives us the count of cars with plastic wheels. And so I'm going to copy this right over here. And I'm going to put it right there and spread it out a little bit. So count of cars with plastic wheels. I want to put this a little bit lower. I might be a little OCD. Okay. And then the next thing that I'm going to do is I am going to get, instead of the count, I'm going to show values as percent of grand total. And so this is the relative frequency of cars with plastic wheels. And so I'm going to just copy this. So I copied everything. I did not copy the grand total. I do not want to copy the grand total. I only want to copy these values right here. And yeah, so we've got count of cars with plastic wheels, count of cars with, we've got the relative frequency of cars with plastic wheels. And we've got the count of cars or frequency of cars with plastic wheels. So we've got all the data that we need for the cars with plastic wheels. Now we're going to go to the cars with the rubber wheels. And so I'm going to get rid of that and I'm going to put rows and values. So I've got rows and values. And once again, we're going to change instead of sum, we're going to do summarize values by count. And we're going to group this. And we're going to group it the exact same way. So where does it start? It starts at 2.6. Starting class lower limit is 2.6. So we're going to right click right here and do group 2.6, and once again 0.4. And so we've got count of cars with rubber wheels. So I'm going to copy this and I'm going to put it right here. And so we've got that information as well. And now what I'm going to do is switch this, show values as percent of grand total. And so I've got all of this information as well, and I'm going to put it right down here. And so now I've got count of cars with rubber wheels, except we want relative frequency and frequency. Okay, now the next thing that we need to do is we need to, which I'm gonna just delete these, get them a little closer together. We need to make sure that these line up, okay? 2.6 to 3, 2.6 to 3. These are a little weird because there's nothing here. So what it does is it just gives you a blank. And so because there's nothing there, so we're going to put 2.6 to 3 and we're just going to put 0. That's more or less what they did, but they just did it in a slightly different way. And then after that, 3 to 3.4, this matches up, 3.4 to 3.8, 3.8 to 3.8, okay, 4.2 to 4.6, 4.6 to 5, 5 to 5.4, 5 to 0.4 to 5.8, and then this is the first one that does not match up. Okay, so we're going to, I'm pressing Control X, or you can also do cut, and then I am going to paste. So I cut it and I pasted it and it moved it down. So now I can put a new call or a new value right in here, and it's going to be this same value right here. So Control C, Control V. There's one more thing that I need to do. Notice all of these, there's no gap between any of these, except for right here, okay? We need to have another class in between here. So I just cut all of this. So right click, cut, and then I am going to go one cell down and do paste. And right here it needs to say 5.8 to 6.2. And then we're going to do 0. And we'll do the same thing over here, 0. And now we've got everything matched up on both sides. And then we're going to do the same thing down here. It's going to be the exact same process. And then we've got 6.2 to 6.6, and it's going to be 0. Oops. And then once again, we're going to cut, paste, and then this 5.8 to 6.2, and once again 0 and 0, and we're good to go. So everything matches up on both. I've got to fix this really quick. There we go. So everything matches up on both of these. So essentially they all have the exact same classes. This has the same class. This has the same class. These all have the same classes, and every single chart or every single frequency table or relative frequency table has the same exact classes. And this is very important. So I'm going to change a few things. I'm going to go rubber wheels, and I'm going to copy this, Control C, and I'm going to do plastic wheels. Okay. And I'm going to do the same thing right here, rubber and plastic. And then I'm going to copy this, Control C, Control V, and that was kind of the whole point of why we did what we just did. So we now have right here a frequency table, and we also have the relative frequency table, and we don't actually need this anymore because we already put all that data right here. The plastic wheel data is all right here, plastic wheel data is all right here, and so it's all together in one area. Now I'm going to show you why I made both of these. Technically, this is really the only one that is important to us right now. There are a lot of situations where you would want the count, but the reason why you'll see in just a second, we want the relative frequency is for a very specific reason. So I'm going to highlight this and I'm going to do insert, and I'm going to click on this and click like that. And I'm going to name it, and it's going to be frequency of track times by tire type. Okay. So we've got frequency of track times by tire type. And then what we see right here is a lot of the plastic wheels are right here in the 3.4 to 3.8 range. That's the max, or that's the mode, if you will. And then you can kind of just see where they taper off to on the ends, but it's really, there a lot of them are right there and then they taper off. And so it looks fairly normal-ish, but it is definitely skewed. But down here, the rubber wheels, comparatively, it's like, okay, it's just really widely spread out. It's really hard to read it because it's, the reason why is because rubber wheels, there's only, 60 some odd observations, but plastic wheels, there's over 800. So you see a whole lot more representation in this graph of plastic wheels than you do of rubber wheels. So that's why we need to do this relative frequency table. And so I'm going to highlight all of this. And so this is like comparing apples to oranges right here, with rubber wheels to plastic wheels with frequencies, when the frequencies are so different. So here we're going to do insert, and this is a relative frequency. Okay. Relative frequency of track times by tire type. Okay. And so you can see here, rubber wheels are definitely still, above over here. They've got more of a concentration that's higher. But now it's comparing apples to oranges because you're essentially comparing the exact same amount on both because it's out of 100%. And so you're able to see the two distributions stacked on top of each other in a much more, understandable and applicable way, or honest way, if you will. There's one more that I'm going to show you how to do, and I'm going to copy this and put it right here, and it's going to be called the cumulative relative frequency polygon. And this is a really good tool. I'm going to do equals this, okay, equals this, then we're going to do equals this. So we've got the second value plus whatever's in front of it. And then equals the second value plus whatever's in front of it here. And so what I just did is this is always going to be added to whatever is next, and now I can just literally drag it down. Okay, and it's going to go to 100%. So essentially what I did here is this value right here is these two combined. This value right here is these three combined. This value right here is these four combined, so on and so forth, going all the way down. And so I'm going to show you what a cumulative relative frequency polygon looks like. So insert, and we're going to go like this. And what you see here, and I'm just going to copy this. Okay. Cumulative relative frequency of track times by tire type. And you can see that the plastic cars, the majority of them, or they go the ones that 3.4 to 3.8, they're already at over 80%, are 3.4 to 3.8 or less. And so that's a really good tool. And then you get 3.8 to 4.2 is right here. And you can see this is, in my opinion, a much better visualization that shows you that the plastic wheel times are shorter than the rubber wheel times, and the rubber wheel times are higher, because the majority of them are still, or actually right about here, 50% are below this, where they're 80% are more than 80% are below this. So this is a really good tool as well to help you to interpret the data that you're working on. And it's really easy to make after you make this one as well. It all has to do with the data that you have and what you actually want to communicate. If you've got counts that are really similar and you'd rather display counts than the relative frequency, you can do that. But if your counts are really different, you should really display the relative frequency. And if you want to show the cumulative frequency, if it's beneficial for interpretation, you can definitely do that as well. And it's pretty easy to do that. So that's how you make the frequency polygons. And yeah.